Again, my name's Howard Butler. I have a company called Hobu Inc. We're located in Iowa City, Iowa. We do all things point clouds. We lead the Poodle or PDAL project, Point Data Abstraction Library, some of you may have heard of. We also developed the cloud optimized point cloud specification. I'm going to talk a little bit about that today. But I have a public service announcement. How many of you, by show of hands, use GDAL? Most of you? All right, great. How many of you like GDAL? No, I'm just kidding. Okay. I lead something called the GDAL sponsorship program. And GDAL is kind of special in our industry. I don't think we can deny that. And I kind of consider it as like an operating system of how stuff works. And it's a place where a lot of the practical interoperability of our industry works. Like getting something added to GDAL means its distribution of capability across our industry is huge. And we have a sponsorship program that this current year's sponsors help support the maintenance and development activity of the project. So the business model of GDAL had always been that XKCD cartoon, which is the one dude in Nebraska. And the problem with that, of course, is that person using consulting money to fund the maintenance of a large open source software project is just not sustainable. And so we changed the business model of GDAL to that the maintenance activity is funded by our sponsors. Consultants can continue to add new things, add new capabilities, and do what they want with GDAL, but answering tickets and emails and questions about this and documentation about that and the red X on the continuous integration that's maintenance activity. And the sponsorship program supports that. So if your organization depends on GDAL, please consider helping us by sponsoring it this year. Everyone's budgets maybe are contracting or changing or are in flux in the next year or two, certainly, and that might not be, GDAL is no different than that. In the last year, GDAL sponsorship, throughout the lifetime, we've raised nearly $1 million for GDAL with the GDAL sponsorship program, and some of these activities are capabilities, features that y'all are going to either currently using now or going to get to use. The biggest one, of course, that I'm super excited about is we did a user survey last fall, and it was complaining about GDAL time, and one of the biggest complaints was, I really don't like the command line interface to GDAL. It's all these different little commands that do all things differently and not consistent, and that is going to be updated quite significantly in the next release, so I hope you like it. Okay, enough about my public service announcement and begging for money. I have a question. Is data mass? Like, does it exhibit the properties of mass? For us, it seems to. We put data places and it attracts computing. Once the data starts to get large enough, we're really seeing this accelerate, right? Inertia makes it really tough, once we put it in these places, to move it somewhere else. It bends our technology architecture's fabric. We are contorting ourselves to react to this property. Maybe it's the property of gravity. I don't have an answer for sure to that, but maybe it's an apt characterization. And of course, network distance, the proportionality. The last question and the last one is, can I operate on your big XAR data set in my own cloud? That's a really long ways away from where you have this big pile of data. So I guess I would posit that cloud-native geospatial architecture is a reaction to this kind of property of data having gravity for us. Once it gets large enough, this starts to really matter for us. And what we've done over the last maybe 8 to 10 years, especially starting with maybe Landsat, way back, let's put Landsat in the cloud, Jed's big project, is the clients have gotten much smarter and the servers have gotten much dumber. Right, so in the bad old days, you had a big OGC server, and I had a WMS, and I had this big protocol, and it was RPC, and I made this query, and it did a bunch of work, and it handed me my data. Now all of that stuff happens on the client. Like the data's sitting there, it's on a server. The server's very dumb. I hand you bytes. The client's very smart. It knows the data. I can ask questions of the data to tell me how it's arranged, and then I interact with it that way. The applications control how they traverse that data. They control how they access that data in parallel ways. They control how much volume they're going to grab back to them. And that's really important for how these applications need to work to be able to perform. So the phrase I use is data is a service, or everything as a service these days. But like sitting at rest, this data just sitting there over an HTTP server can act as a service. I think that's the property of cloud-native geospatial. But the hammer we all have to do cloud-native geospatial is this one. How do you chunk your data, right? So you'll go to every presentation next couple of days. Way down in the details, ultimately, it's chunking. How do we chunk the data? We can chunk the data into lots of little files and spread them across an object store. That's one model that works really well. ZAR, TileDB, some of these other things do that. We can store all the chunks in a single file. That would be cloud-optimized GeoTIFF, right? And we have an index that points to those things, but ultimately they're chunks. So how you're going to chunk the data, and the hammer that we have to deal with this gravity problem is divide and conquer, chunk the data, right? I would say our big bang, at least in this, of course, is cloud-optimized GeoTIFF. And the data was, the Landsat was large enough that the complexity of pushing the index to the front of the header, making GDAL like smart enough to talk over HTTP to figure out how to access what content it was going to access, made it worth the trouble. The data is just large. Like this data gravity thing is like contorting our architecture. GDAL got a lot smarter. But GDAL was also like a key distribution of this capability, right? Like once it was released in GDAL, everybody had this capability. We could all speak cloud stuff. So can we do that for point clouds? So my company had worked on developing data organization for point clouds. We have this other, I call it exploded object storage approach called entwined point tile, which is great. Except you have to convince everybody when you make a new thing, support my new thing. My new thing's awesome. And all you have to do is like invest a whole bunch of energy, data translation, software development, and everything else to get your software systems to use my thing. I can pre-populate that with a whole bunch of data. I can make it easy for everybody to use it, but they still have to like make the cost determination themselves whether to do it. With COGs, they didn't have to do this. All this old software could read TIFFs forever. They didn't have to change their software to get the specialness out of a COG because they didn't need it. They just want the bytes. But if they did, they could opt into it. So for point clouds, we want the same property. Like, what's the format everybody's point cloud software can read? We want to opt into this special capability that we want, which is to access the chunks and have a client that's smarter. But in the end, we might just want the bytes. We just want the points. And so, again, COG, but for point cloud. So in point clouds, we have LAS, which is kind of the common schema that, I don't know that anybody does much point cloud stuff here, but it's kind of the, TIFF is not quite the right analog. Shapefile is probably more like it. Hated as much as shapefiles. And, it has like 20 possible layouts, combinations. It has coordinate system challenges. I mean, it's got all the misery of all of these 25-year-old legacy formats. And then there's a compressed variant called LAZ, which is very efficient, quite slow, super complex, but it's also used everywhere. It's open source. And so can we take those things and add the part that we need, which is chunk the data and access the data according to those chunks with a smarter client? And so that's what Cloud Optimized Point Cloud. You might hear me call it COPSI. You might hear me call it COPIC. There's actually a section in the specification about possible pronunciations for it, and I don't really care. But the idea is, again, with a cloud-optimized GeoTIFF, you have an index that says, here's the locations of all my chunks. If you read this index, you'll have all of the locations of those chunks in your very smart software client. You can figure out where to go and read only the bytes that you need over HTTP. As simple as that. This adds missing capability to the kind of the formats de jure in point cloud, at least the file-based point cloud formats, which is providing spatial window access, meaning I want to select data for a particular window or I want to select data for a particular resolution. And those are the kinds of things we might do in raster data as well, but they're really important in point cloud data just because applications need to control the volume of content that they're bringing across over the network. Again, that proportionality thing, that's a challenge. So how can you read these? So there's plenty of open source tools and closed source tools now available to do this. The COPSI specification, we released it in December of 2021, I think it is. So we're almost 4 years down the road. Of course, we have an open source library that lots of people use as well called Poodle. And so, our first implementation was there. It's not the fastest. It's the most flexible and most convenient. There's other tools. If you drop a LAS file into QGIS, internally it's going to convert it into COPSI and then start visualizing it and displaying it right there for you or processing it. JavaScript libraries for doing it, Rust libraries for doing it. Plenty of open source capability. How do you write these things? Again, Poodle is available. QGIS is going to do this for you. There's a couple specialized libraries. The other processing, LiDAR processing library that everyone uses is called LAS Tools. That has wonderful support for COPSI as well. And the closed source tooling is starting to adopt as well. FME was a big early on supporter. RI Process, that's Regal, so that's one of the laser scanner manufacturers. You can actually access for their data in COPSI. And then, of course, typical GIS software like Manifold. How to view them? Again, QGIS, that entire closed loop, read, write, and view. Poetry, which is an open source library for interacting in browsers, that's kind of point cloud focused. And then a little bit of a sales pitch. We have a library called Eptium, which is based on Cesium. It's like Cesium.js is awesome, but I don't necessarily want 3D tiles. I want to be able to render cloud optimized GeoTIFF and cloud optimized point cloud directly in Cesium without having to reformat petabytes of content that I might have in COGs or COPSI or whatever. And so, we have some capabilities there. It's freely available online at this web address, but it has our logo splashed on it. And but it'll do things like read stack catalogs, interact with COGs, and so on. There's also a Jupyter widget that we're just releasing, which allows you to stick it into a notebook and do the same sort of thing. So if you want to splat a cloud optimized GeoTIFF in 3D or a cloud optimized point cloud on some data source, you can do it that way. And then finally, we developed another website, or just a location where you can drag and drop a COPSI file onto it, and it'll go interrogate and inspect it for you and say, hey, this is valid, or I read this thing, or I want to view it. Just kind of an integrated sort of, tell me about this file. So, again, it's file-based. It's a lot of the LiDAR and point cloud content still is, and exists out there in large archives. So, okay, COPSI, that's cool and awesome, but I don't know. What about Parquet? Can I do point cloud stuff in Parquet? Yes, you can do point cloud stuff in Parquet. You still have the similar sort of legacy geo software challenge, let's say, of Parquet. We can do Parquet stuff with GDAL. You can do Parquet stuff with Poodle as well. But not everyone else's software, of course, reads Parquet. GeoPark, older GIS software. My old LiDAR processing software doesn't know what the heck Parquet is. It's LAZ is a very efficient LiDAR compression. It's specifically written for that, so it's always going to do better. And then the pattern, that thing that makes that smart client smart, is this additive octree. It's pretty tough to develop something like that in Parquet. There's also something called TileDB out there. TileDB works really well. It has sparse array support. But it has this, it's the same thing as ZAR in terms of it's exploded objects, right? You have you presumably are putting on some file system that horizontally scales, and you don't have to worry about creating millions, billions, or trillions of objects. That's great if you only have to write them once and never have to move them. The LiDAR point cloud content, like lots of TIFFs sometimes, they need to be federated around for various reasons. Maybe some people are air gapping content. Maybe some people need to go somewhere where there's no network. Whatever the reason might be, they might need to move content, and so there might be some downsides to that. Of course, Poodle supports these just fine. Excellent capability for them there. What about ZAR? I don't know. The needs, of course, is capability of doing sparse data. You need to be able to describe very precise 3D coordinate system definitions, because at least for LiDAR point cloud content, the 3D part's important to a lot of those folks. And then you'd like some kind of sophisticated compression because the data is really fluffy. It's not information dense, right? If you remove 1 point or 2 points from a point cloud, no one even notices. And you want that stuff to compress down. So anybody wants to hang out and chat about this stuff, come find me. What about GeoPackage? No. Actually, I have done this. There was a driver in Poodle that I wrote to implement this. If anybody wants to see that bad experiment, go right ahead. So that's about all I had for content. So thank you very much, and hope you have a good show.
Do we have questions for Howard? Yes.
Thanks. Do you have any sense of the time saver, twofold, tenfold, 100-fold, working with the cloud optimized point clouds? The reason I ask, I work with a bunch of people. I analyze the point clouds once they're processed, but I work with people who pre-process and wrangle point clouds, and I'd like to bring back to them if there's any, is it a major efficiency time save or kind of factor?
If you're doing full density reads all of the time, maybe not. So if your process is, I'm always going to read all of the points all of the time, no. It's extra. It's like overviews in a TIFF, right? If you know that you're only going to read partially into a file for whatever reason, whether it's for resolution or for a particular window, that's when you get the savings. So, the cloud hammer that you have is, of course, we talked about chunking, but you also have divide and conquer, right? Being able to control how you divide your computing across that data is super important. And so you don't necessarily control your data provider providing content to you and the sizes of that data. And so if you have to reformat that content all of the time, it's painful. You have a full I/O step there going on. And so I would say if your process is custom organized, we always take in tiles that are this size and this many points, and we always read them all, and we don't, probably not much benefit. If you don't know, then there's big benefit. If you want to read off of somebody else's archive, you don't control how they've split that data up. Say your National Agency for Elevation Content provided the LiDAR data for its country, and there are countries doing this now as COPSI data out on an HTTP server. You want to be able to process my postage stamp, not my province, right? And so this allows you to do that without having to assume responsibility for all of those bytes and all of that content.
Okay, do we have more questions? Okay, thank you, Howard.